Okay, we have just started the recording as well. Recording, I'll just confirm the recording. Okay, it is. We are recording now. Uh, can you all please confirm if my screen is visible to you?
Oh, yes, yes.
It is visible. Okay.
Yes, it's visible.
Okay, yeah, that's correct. Okay, so once again, wishing you all a warm welcome to our uh, workshop on process engineering and design. As informed to you in a group earlier, that this workshop is planned to be conducted in three stages or in three sessions. One will be today, and after 1 week, and the week after that. And yeah, uh, the agenda for our workshop is this. And now the agenda which I'm showing right now, it is the agenda for the complete workshop. Means it comprises of all 3 days. We'll be doing this first. Obviously, we'll be starting with a quick round of introduction, and we'll be having a safety moment, and then we will see the objectives of this workshop, and there'll be a brief discussion on general aspects of process plant design. Then we will see about some deliverables which are commonly used in process industry. When we need to sh- showcase our design, the design is made in the form of some deliverables or in the form of some documents. So we'll be looking at some commonly used documents or commonly prepared documents, which every process design engineer is expected to know. Uh, then after that, okay, our aim is to complete up to the deliverables today. And in the next week, inshallah, I plan to go through the basic concepts, which are commonly used in process design. And those are very basic things which every process engineer is expected to know. Uh, yeah, after that, we'll be looking into process simulation software, because as we all know that in the modern day design practice, no design is really complete without using a simulation software. So we'll be looking into that as well. And lastly, we'll also look into some job hunting aspects. And whatever we learn, yeah, our ultimate aim is either to get a job, or to do well in our job, or to do our business or whatever. So we'll be looking into job hunting aspects as well. Updating of CV, applying for job, usually what kind of interview questions are asked, etc. And I would also like to start with a very quick round of introduction. Uh, if you could just mention, if each of us could mention a name, when we had completed an engineering year, when and which company you are working in, where you are based in, and you're from which place, your native place is where. So I would like to start by myself. Uh, okay, I'm Umair Huzuk. It has been 8 years since I completed my engineering. I completed in the year two- 2016, and I'm currently working with Weatherford, and I'm based in Abu Dhabi. and I belong to Murud Chanjera. So if you can start one by one, if Waleed, you could just give your introduction.
Assalamu alaikum everyone. So my name is Walid Javed Dhokle. I basically belong to a town called Mahad in Raigad, and I've completed my undergraduation from Dr. Babasaheb Ambedkar Technological University, Lonere, in the year 2020. So right now I'm currently working in a UK-based company and as a senior process engineer. Yeah, so that's it about me.
Thank you so much. And Noor,
Assalamu alaikum. Uh, I completed my degree in 2021 from Shivaji Rao Jonle College of Engineering. Currently, I am working in Deepak Novochem Specialty Limited in Lote. I belong from Srivardhan, Raigad. Okay, and that's it. Thank you.
Afif,
Assalamu alaikum warahmatullahi I am Afif. I have completed my BTech last year, 2023, from Dr. Babasaheb Ambedkar Technological University, Lonere. Currently, I am working in Deccan Fine Chemicals, which is located at Tuni, Andhra Pradesh. And I am belong from Road Janjira. That's it.
me. Thank you, Afif. Thank you. Abdul Qudus.
Assalamu alaikum team. My name is Abdul Qudus Roge. I am from Raigad Masla, working in more than 25 years in oil and gas sector alone. I am working with ADNOC as a senior HSC engineer. The purpose of joining this code to basically understand how things go behind what I do. We are working on the field. So when we go, we have already there a design and other than we follow those designs for the implementation of process and plant safety. So inshallah with Umer, I'll be understanding the concept much better while I go with him. Umer, back to you.
Inshallah. And is any of it? Waleed, Noor? Okay, fine. All done. So okay, let us continue with our workshop. Okay, as it is a common practice to always start any workshop or start any meeting with a safety moment. We would also be discussing a safety moment before we start the main workshop. So today's safety moment, I would like to discuss about the safety while using LPG gas at homes. This is something unfortunately it is one of the causes of fire at homes in various countries. So just thought to brief some few safety tips over here. One of them being that when you use LPG gas at homes, that ensure that the gas supply valve is open only when really required. Because there are also always chances of leakage happening, or someone might accidentally open the knob, because of which gas continues to come out. So and so it's always advisable to only keep it open when it is really required. Next thing is never allow children to play with the gas well or with the cooking range. And it is always a good habit to keep a fire extinguisher in the kitchen, always readily available, so that in case of any accident, it can be brought to use instantaneously. And if possible, try to have an automated system to trip the gas supply in event of leakage, Now, this is something what is being made mandatory in UAE, in Abu Dhabi actually. In India also, if it is possible, because nowadays I see that it is available at a reasonable price. So it is always advisable to have an automated system. As soon as gas leakage occurs, immediately the gas supply valve should trip. And what to do in the event of a gas leakage? Whenever there is any gas leakage, it is a human instinct to on the light and see what's happening. Like if we are in the dark, we get prompted to immediately go and on the light and see what's happening. But do not do that. The thing what we should do immediately, we should open windows, doors, so that gas can disperse out. And because if we attempt to on any switch, it may create some spark. And if there's a gas leakage, if there's a gas leakage in the kitchen, and if we on a switch, and because of the switch, because of switching on the switch, if there's a spark, there is chances of a fire or an explosion even. So yeah, so it's always these things must be kept in mind, and not just for us, even for the people in our homes. We should keep highlighting this to them once a while, so that everyone is aware about these things. And I believe Abdul Qudus Rahab might have additional points to add. Because
Yeah,
you've
Umar,
been
few big clue. Recently, we have seen a video of a blast in Dongri where a portion of the building blew up, right? I believe you must have seen that video. The gas cylinder was inside the house and then the building blew open. So basically, message for us Konkani is like, for example, we are staying outside. Like in my house, many years back, I found that we are keeping extra cylinders at home, in rooms locked and keep so you can use it during emergencies. So message is do not keep any gas cylinders inside your rooms, like extra cylinders inside the houses when you leave your places in back home in India. That's one. Secondly, as far as possible, try to keep the gas cylinder outside. Many of us, the cylinders are kept inside our home. So we should try to see if the conditions permit or we are possible to do. The cylinder should be kept outside. The source should be out, so the impact can be lesser in those times. Umer.
open for it. Mm.
And one more point which Umer has rightly identified is regarding the switching of the lights. You never switch on the lights. I had a witness one event with one of our colleagues where his mother had to go. The gas was leaking, and the lights were switched on, and it turns as a source of ignition and which caused a blast. So these are very important points which we need to maintain from day-to-day basis. Team, back to you.
Okay, valuable points. Before I continue with the next with the workshop, just wanted to highlight one or two points. Is that if you have any queries, always feel free to stop me, and we can discuss on it more until the query is cleared or until it is addressed. Okay, that's it. So till here, anyone has anything to add or any additional request or any point to say, or we can continue further?
Umer, can you share the agenda of today's meeting?
Yeah, sure. This is the agenda. We'll be looking into objectives, then some general items, then about deliverables, commonly used in the process industry. Then in the next week workshop, inshallah, we'll be looking at this, which is some basic concepts used in process design. About some of the simulation software and something about job hunt. Okay, so let us go to the objectives of our today's workshop. At any point of time, if there's some issue, like either my voice is not audible or my screen is not visible, then please highlight it so that we don't lose time. The objectives of the workshop is one of them is to bridge the gap between academics and industry requirements. As many of the people who are joined are actually freshers who are not more than 1 or 2 years of experience. It is always this workshop can serve as a tool to bridge the gap, like between what you have learned in your academics and what is really being applied in industry level. There tends to be some gap. So inshallah, up to a good extent, we can fill the gap. Another objective is to provide an insight into industrial procedures of process plant design. How a process plant design activity is carried out. We will be looking at that as well, and this workshop will also serve as a revision for some of the process, or you can say some of the most commonly used process design concepts. And with this workshop, we will also highlight some of the interfaces between process design and other disciplines. There's always a link between process design and other disciplines such as HSE, instrumentation, piping, mechanical, etc. So we'll be looking at those interfaces as well. And this will also, inshallah, this will also be a guidance for those who are looking for a job in the especially in the field of process plant design. So these are the objectives of the 3 workshop, of the 3 sessions which we will be having. So let us start with the general process plant design. Let us start by defining exactly what is process plant design. Well, it is the sequential approach of developing the plan, calculations, drawing, and philosophy of a process plant in order to completely define the process inputs for building of the process plant. Just to understand the definition better, let us just consider an example of building a house. Suppose you want to build your own house. Before you build a house, what is the first plan what you do, or what is the first thing what you do? You appoint an architect who makes the overall plan layout of the building or of the house, and then it will be worked on later further. So the basic thing, or the basic approach is for building the house is the architect's work. So, and what architect does? The architect does make some plan, make some calculations, makes a structured approach, and then the architect's work is developed. Yeah. So in the case of a process plant, always the process engineer's work is the first. Like the design activity will always be started by the process engineer, and his work is to develop a structured or a sequential plan, calculations, drawing, philosophies, and the process engineer's activity will be such as to based on which based on which the process activity or the process inputs will be completely defined in an organized manner. So yeah, it's all about all about developing some plan, calculation, philosophy, etc. So that is all about process plant design. One more aspect we'll see why process plant design. As we all know that each field or each profession has its own significance. So what is the significance of process plant design, or why do we learn about it? Or yeah, it has something what it has got one of the highest scope in the chemical process industry. Like for any process plant design, especially for the big for major plants, sometimes more than 50 or more than 100 process engineers have to work for the time span of 1 to 2 years in order to complete the process design. So it has got one of the highest scopes. Might not be the highest, but definitely one of the highest scopes in the chemical process industry. And another thing is that it has got very high application of analytical skills, what is learned in academics. We might have heard before, it was something commonly, the common perception that what we learn in college, we don't use in industry. Okay, and yeah, that varies from case to case basis. There are some few industries, basically the various kind of fields in which chemical in the engineer can go into. He may go into R&D, he may go into design, operation, sales, marketing, etc., etc. So the design field is one of the field in which very high application, or whatever we learn in academic level, many of the concepts are being applied, unlike many other fields. And obviously, yeah, it is one of the highest paid jobs in the chemical industry. Because and another thing is that design means something which is being created as new. It's not like a daily operation. What every year, I mean, every day and every year we need to keep repeating the same thing. It's not like that. It is something what is every day is new, or every design is different. Till here, if anyone has any discussion or anyone wants to add anything, please feel free. Okay, so let's continue further. So now we see about some aspects of a project.
Umar, are you sharing
Yes.
some slides? Because the slides are not moving.
Not moving. Okay. Not sure why. I'll just just now it stopped moving, or it has been like that since before? I mean, since some time.
Since the start.
Oh, since the start it was like that. Sorry, sorry,
Yeah.
sorry. I wish that anyone of you would have told. Sorry for it. I am not. It shows that I'm presenting all here. Stop presenting. Oh, very sorry for it. Uh, mm, please. PowerPoint. Now is it visible now?
The first slide only. So it's only showing the first slide.
The first slide? Oh, okay, sorry.
Safety moment slide.
Only the safety moment slide. Okay, okay, is it moving now? One second, sorry. Is it moving now?
No.
Okay, let me just do this thing. How is it visible now?
No.
And it is moving as well.
Yeah, now it's
Try now.
moving.
Not moving, right? Okay, great.
Yeah.
Okay, since we had missed few things, I believe since start it was happening, let us have a very quick brush through the things what we have seen already. Mhm. Just we'll start from the agenda onwards. Like agenda was using that we'll see some general aspects. Then we'll be looking at some deliverables or some documents which are usually made by process engineer, and then we'll be looking at some basic concepts which are used in the process industry, and we'll be looking about the simulation software as well, and also we'll be covering some process engineering job hunt topics. Yeah, we had seen a safety moment, and we had seen the objectives, the objectives of this workshop also were seen, and then we had seen about basically about what is process plant design all about, and we had seen why process plant design is important, or what the significance of process plant design. So till here we had seen, until here, if anyone wants to know anything more or wants to add anything more, please let me know.
Yeah, Umar, like I have this question. Like most of my juniors, they ask me this. Like, what is the better way to have this transition from the academia to the design field? So, and what are the preliminary requirements to get into the process design, based significantly to process design? So, could you please highlight some of the points so that I could share with them? Because what I could share that for example, whatever you are been doing, whatever you have been learned in the academia for 4 years, you just stick to that basics and you apply it in your initial stages. Anything apart from it, if you wanted to add?
So, although the answers for your question could be varying, from different people who can have different perspectives, I would like to answer this question based on my experience and based on what I have what I have heard from my colleagues as well as from my juniors. One of the thing what you should do if you want to move into process design, you should have a strong background. Or if you feel that you don't have a strong background on the basics, you need to develop a habit of keep reading. Whenever you have free time, keep reading something about process design. I mean, start from the basics, like say line hydraulics, heat exchanger, and all. And start from the basics, and then keep reading. And if keep reading from different places, like can be books, can be some online articles, can be some API codes and all. And if it is always advisable to have a course, there are various courses available. So I would personally advise to do some relevant courses on process plant design, and also try to cultivate a habit, to use some case studies, and and you can create your own design first from schematics, and you can, if you have access to any of the simulation software, you keep using the software as well. So yeah, these are some things what can be done as per my opinion.
Okay, Umar. Jazakallah.
Fantastic. Okay, so let's move on to the stages of project. Any project, be it small or big, has to go through these 6 stages. For the big projects, each of the stage will be clearly defined. I mean, clearly there will be a defined scope, or there will be a defined stage. First we'll start from, say, study, we will start from SS level, then move on to feed, etc. In small scale jobs, sometimes 2 or more stages are combined into one. But yeah, nevertheless, there will always be these 6 stages for any process plant design activity. Let us look into the details of each of the stages. Yeah, we'll start from the first one, which is the concept study phase. What is done in the concept level study phase? The very basic thing, like for which technology would we use, then some basic diagram or basic flow sheet which will be used. Those kind of things will be defined in a study phase. One simple example: if I want to do a gas sweetening, or if I want to have a gas sweetening unit for my facility, by saying gas sweetening, basically it is removal of H2S and CO2 from a gas. So do we use a amine sweetening unit, or do we use a membrane unit, or no? Do we use a membrane suppression unit, or an amine unit, or anything else? It is one example. Which technology we use, what unit do we use? And once we have decided on a unit, there will still be several basic parameters, like suppose a liquid needs to be heated and pressurized before it is being fed into a distillation column. So do we heat it first, or do we pressurize it first? Like a heater should come first, or a pump should come first? Those kind of basic things, like equipment configuration, which equipment first, which second, third, whether any equipment should have any bypass or not. I mean, those kind of basic things are established during the concept study phase. And what is the ultimate objective of a study phase? Ultimate objective is to define the technical requirements and thus establish the economic parameters. By saying economic parameters, it is calculation of ROI, means return on investment and payback time. What is return on investment? Suppose I spend 1 million today, and after 10 years, I'll be getting 8 million, suppose. So ROI will be 8 million upon 1 million. It will be 8. So I'm spending certain amount now for developing of the process plant design. What is the return on investment what I will get in a particular time frame? So that is the ROI. So ROI will be established, and payback time. If I spend a particular amount now, and in how many years or in how many months will I get back the amount? Normally, a payback time of say roughly 5 to 8 years, 2 years, something in that time, it is considered normal and it is considered economical. Suppose I invest, I or some company invests a particular amount, say $100 million for developing a process plant, and I'll get the amount back. Maybe after 3 years, I will start making profits, and say within 5 years, I'll get the amount back. So usually 5 years, 5 years time, or the payback of 3 years, 8 years is considered good. But say if the payback time is say roughly 40 years, 40 years later, I will recover the amount. Means the design will not be feasible. Yeah. So these kind of assessments are done during the study phase. And obviously, process engineer's role is most required during the study phase. Okay. With that, we are done with the first phase. Now, once the study is established, once the technology is already selected, once the equipment configuration, this first, second, third, fourth, 10th, 20th, etc. All the equipment configuration is established. That is the end of the study phase. Next will be the feed phase. Feed is actually front-end engineering, and in a feed, the complete engineering will be carried out. All the documents, what we will be seeing it today, inshallah, all those documents will be developed by the process team. And not just that, feed is usually done to a detailed level up to the last nuts and bolts. How many nuts and bolts will be required? Maybe 1,000, maybe 1 lakh, or anything else. And how many cables will be required? And approximately what will be the cable length? What will be the length of each pipe? So till that much detail, the design will be developed in the feed phase. And obviously, process engineer's role is very much required during the feed phase as well, because it is the process engineer who has to initiate the design, and based on the design of the process engineer, other engineering disciplines design will be done. And assuming if the process engineer himself has not done a good design, or if he has done some mistakes in the design, then obviously other disciplines design may also not be well. So process engineer's role is the most critical. It is the start point. So why now? Why the study phase was done? We already discussed about it. Yeah, that study is done to establish economic parameters and to develop the flow sheet. Why the feed is done? The ultimate purpose of the feed is that based on the feed, the engineering contractor or the EPC contractor will quote his price. The EPC contractor, the main contractor who will do the procurement, construction, commissioning, and all, he needs some basis so that he can provide a quotation, right? And the basis for him will be the feed. In the feed, all the entire design of all the relevant engineering disciplines will be established. Like mechanical engineer will do the design for his equipment. Piping engineer will do the detailed design for all the pipes. Instrumentation engineer will do the design for the instruments and automation system. Electrical engineer will do the design for all the electrical equipments, cables, and all. Likewise, the design for HSC, civil, architecture, etc. will be carried out. And based on the entire engineering package developed after the feed phase, the EPC contractor or the main contractor will provide his quotation. Okay, so next we move on to the detail engineering phase. The detail engineering is carried out by the main EPC contractor, or sometimes it is outsourced, but it is the EPC contractor's responsibility to carry out the detail engineering. Now, whatever engineering was done during the feed, same engineering will be repeated during the detail engineering phase. And the detail engineering is done after the EPC contractor is appointed. So the detail engineering is conducted by the EPC contractor. And one question may arise as why engineering, which was already done, all the documents, all the drawings, philosophies, everything was already made during the feed phase. Why do we need to repeat the engineering? Before we look into that, let us try to understand something about a cost perspective. Many of the senior engineers who are over here may also agree, and this is based on my observation of projects, that out of the entire cost, out of the entire engineering, or out of the entire cost for developing a process plant, the cost for engineering is not more than 2 to 5%. Like if the cost of developing a plant is 100 million, suppose, the cost of engineering will be 2 million, 3 million, maximum 5 million, not more than 5%. So it is always, and the major cost is for the procurement and construction phases. Since the engineering cost is comparatively very low, and engineering is the most critical of all aspects, a good engineering will lead to a good procurement and construction phase. So it is always wise, or as per company best practices, it has been an established way to repeat the engineering once again. Whatever engineering was done during the feed, same engineering will be repeated during the detail engineering phase. Another thing as to why the engineering is repeated once again is that during the feed phase, it will just be engineers. It will just be a group or team of engineers who are working into it. But during the detail engineering phase, the vendor or the manufacturer will also be appointed on board, and there will be close coordination, or the engineering contractors will liaise with the supplier or with the manufacturer, so that they have more clarity into the design. An example, Suppose during the feed phase, the engineer has specified that they need a vessel whose height will be 8 meters. Okay, the height of a vessel needs to be 8 meters. But during the detail engineering phase, while we have been in touch with the vendor, we know that 8 meter height is not available in the market. It can either be 8.2 or it can be 7.4. No? Either not this much is available and this much is available. So the detail engineering will have the detail engineering contractor will have to change the design. Not 8 meter, he will have to change to maybe 8.2 or 7.4. Based on the exact availability in the market, he will have to change the design. This is just one example, like that there can be hundreds of other examples as to why there are some minor changes in the design based on vendor inputs. That is one of the reasons why engineering is repeated. Another thing is that there can always, even though during the feed phase, the design was already made, checked, rechecked, approved, reapproved, but still there is always room for some errors in the design. So that is why it will be the detail engineer's responsibility to review completely the design of the feed engineer, and the detail engineer has to own the design. Whatever the feed engineer had done, now that's over now. The detail engineer has to either take the responsibility for the design, or he has to change the design. Either he approves, he acknowledges, CIS, so and so design is already correct, I take the responsibility. Or if he feels that something was not done well, it is detail engineer's responsibility to change the design. So yeah, that was a few of the things about the detail engineering phase. And obviously, again, the process engineer's role is very much required in the detail engineering phase as well. Next, we move on to procurement phase.
Umair, do we call it the feasibility study as well? The same thing? We also hear
Yes,
the word feasibility study. Is it different from this?
yes, the feasibility study is actually the concept level study. The concept study, the first thing what I discussed, that is also called as the feasibility study.
Okay,
Yeah.
thank you.
Now, the first three stages, what we
Yeah,
have
Umar,
seen. Yes, sir.
sorry to barge you in between.
No
Actually,
problem.
I just have this query, like this ROI and payback periods. So this is what the process engineer decides, or this is all dependent with the higher management?
Yeah, this is also something what the process engineer is actually expected to establish these economic parameters as well. The higher management will just do the approval and all. Like approval lies with the higher management, but the process engineer has to establish these economic parameters, and that is also one of the reason why we all who are amongst us has done chemical engineering. Chemical engineering core topics back in academics, we had economic analysis as well, right?
Okay.
The first three stages what we have seen, it is concept phase and feed phase and detail engineering phase. Till these three phases, it is just on paper. It is just in documents on paper. There's no real equipment what we can see, real equipment or real instrument or any item we cannot see. I mean, it's all on paper and all on computer and all on documents. So from the fourth phase, the real equipment starts. So the fourth phase is the procurement phase. Means procurement means basically purchase. The whatever design was carried out as a part of the entire engineering package. Now there's someone who needs to start purchasing those items. Items means here includes equipment, instruments, pipes, item for the civil and civil items, HSC related items, and etc. And this is something what usually I can say there will not be any significant process engineer's role during the procurement phase. And one thing to be noted over here is that again, usually process engineer does not directly deal with the procurement person or with the vendors, because process engineer is all about developing a basic scheme or basic design, and it is the other engineering disciplines who has to directly liaise with the procurement person and directly liaise with the vendors. One or two examples just to elaborate my point further. The process engineer will do the design of a vessel. Can be a separator, can be a column, but it is mechanical engineer who has to own the vessel. I mean, he has to own the detailed design of the vessel. Like, for example, what should be the thickness of nozzles? How many nozzles should be there? Should it be from the right nozzle, or the hole should be punctured from the right or from the left, from the side? I mean, those kind of detailed items will be covered by the mechanical engineer, and it is a mechanical engineer who will directly coordinate with the procurement person, with the vendor. Likewise, for instruments, process engineer's job is just to tell that in so and so location, I want a flow indicator, and it has to operate from a range of 100 to 180. Suppose that is all what and it has to have so and so design conditions. That is what the process engineer has to tell. But the instrumentation engineer has to take the responsibility for carrying out all the detailing of the instrument. Like, for example, what instrument class it will be, what kind of automation link it will have, hardware link, software link, etc., coordination with the vendor, etc., etc. So all the detailing will be done by other engineering disciplines. Yeah. And once the procurement phase is completed, next will be the construction phase. It is basically the physical installation or assembling of all the equipments, pipes, instruments, etc. in the field. In the construction phase also, usually there will not be any significant process engineer's role. The last but not the least is the commissioning phase. Commissioning is the initial operation after the construction. After the equipment has been purchased, after it has been brought into the site, constructed, assembled, installed, everything done. Once the process fluid first starts to flow, that is called the commissioning phase. And the commissioning phase has got its own challenges. It is commonly said that commissioning phase is the most challenging phase of all. Because in the design phase, it is just by using pen and paper, or just everything is stored in the form of documents. But the real challenge is seen in the commissioning phase, because even though the design was done well, everything was done good, but still usually there will be several challenges once you start to operate for the first time. Just an example, one of my earlier colleagues was saying that there was a major project with ADNOC. It was some offshore job, and just the commissioning took 5 years. Like it was initially it was planned to do the commissioning in 1 year, but it actually took 5 years. So the several challenges usually experienced during the commissioning phase, but again, the norm is that if the design is done well, commissioning will usually be easy. And again, process engineer's role is very much required during the commissioning phase as well. So, till here, if anyone, okay, after this slide, it will be our next topic. So we pause for a while. If anyone has to have anything to add, anything to ask?
Sir, there is pre-commissioning activities also there. Okay, I want to know this, the process, what will be the process engineer role in the pre-commissioning activities, like tank calibrations and PNID checking work, like this.
Okay, this is something what I'm not the right person to answer it, because personally I have never done a pre-commissioning work. I had done commissioning works, but never been on pre-commissioning works. But yeah, I'll just tell the very basics that for before any commissioning activity is started. Before any commissioning activity is started, there will be several activities what has to be done, mainly by the process engineer and also by other engineering disciplines as well. So this activity comprises of the very basic thing is that during the design phase itself, during the feed or during the detail engineering phase, there will be a document called as pre-commissioning and commissioning philosophy. So this will outline all the commissioning aspects of that particular plant. And the several other activities like PNID has to be checked in detail. Several other documents have to be checked before the commissioning activity starts.
Okay, sir. Thank you. Also there is one basic engineering package. Okay, so what is the difference between this feed and BP?
Now, also, that is also something what varies from region to region and from company to company. Like for the feed itself, what I have explained, it is all based on my experiences with ADNOC. Now, for ADNOC, the feed stage, the feed or the front end engineering itself has to be done in a detailed manner. Now, in some companies, like I had worked for some company in India sometime, and there they had established that in feed, it is only the process engineers design. Like all other engineers design, like mechanical, instrumentation, electrical, etc., that does not come into feed. So they call that as a basic engineering package. What are the process engineers design was done, that they term it as a basic engineers package. Yeah, it is varies from case to case and from company to company.
Okay, sir. Thank you.
Just one more request to all of us, if you can just address me by my name, Umair.
Yeah, Umair bhai, just I want to add few things. Like
Yeah,
someone
sure.
asked about pre-commissioning activities, right? Like
Yeah.
in my previous company, I had that pre-commissioning as well as commissioning, as well as decommissioning of a plant. So basically, like, pre-commissioning is something before just if you're introducing some hazardous, if it's a solvent, or if it's something that is hazardous in nature. So what we do is, before just introducing that to the plant, what we do, we just check out all the equipments and all the moving parts, whether they're working good or not, whether they're moving, or like for example, the pump, the rotation of the pump, how is it, and everything. Basically, we have this checklist called as a pre-startup safety review. So that like that, we have a pre-commissioning checks as well. So we just take into account all these things, and for different domains, like it's a mechanical thing, it's an instrumentation thing. So all the relevant domain engineers, they just check whatever the things they've installed, they're working good or not, before just introducing any hazardous solvent or say any fluid.
So Umer and Walid, to add, what happens is a project is divided into systems and subsystems. So what happened during a project, the construction time, they define, okay, this is our subsystem for building will be, for example, SS BLD. So when the subsystems are combined, and then you have a completion of one system. So at one phase, when the construction is over, at that time you have something called mechanical completion certificate. Once it is mechanically complete, the construction element is over. There is a phase called checking of the subsystem, like functionality checks and all those things. And before it is completely commissioned. So what happens? Some projects they can consider this as part of construction. Some consider it as part of commissioning. There is no concept of pre-commissioning. So pre-commissioning can be part of your construction activity, can be part of the pre-commissioning activities, because it's a phase between construction and commissioning where you are checking the readiness of the particular subsystem, like functional checks of the loops and all those things. And then once the subsystem is okay, then you go for the systems. After that, the next phase comes commissioning, when you're totally ready to start up the process or the system altogether. Umer.
Yeah, I totally agree, Dr.
And what Walid was highlighting in the PSSR, like introduction of hazardous. For example, we have a subsystem called hydrogen, HCl. So if somebody wants to test this line, so before you test this line parameter related to hydrocarbon, for example, and then the HMICL hazard material checklist will be prepared, or the PSSR checklist will be prepared, and people will review for that particular hazardous subsystem the readiness of the system, mechanically complete, all the functional test has been done, fire and gas readiness is there, everything, and then after it is in a state of readiness to commission itself. Yeah, Umer, back to you.
Thank you. Thanks for the explanation. I also got to learn something new today. Okay, so let's move on to the deliverables. This is our next topic of this workshop. Let us look into what is meant by deliverable. Literally, deliverable means something what can be delivered. You know, a package from say Amazon or Myntra or Flipkart or something. What is delivered to our house? It is a packaged thing, and it comprises of whatever we have ordered. And usually it is, it will be kept in a neat and orderly, organized, structured form, such that when anyone looks it, he feels good. So it is now, and here in the terminology of process engineering design, or in the terminology of a project, deliverable means some document or some kind of engineering package which can be delivered to the concerned party. It can be delivered to other engineering disciplines within the engineering company, or it can be delivered to the construction person, or it can be delivered to the client, and such that it should have a meaning. Whatever design was made, it is ultimately prepared in the form of some documents which creates a particular meaning to the concerned party. So when we talk about process engineering deliverables, we make some documents, some drawings, some kind of calculations, philosophy, such that other engineering disciplines who reads our design, like, they should be able to create a meaning, or our design should impart a structured meaning to them. That's about the deliverable. The most basic deliverable what is made during any design is a BFD, or a block flow diagram. A BFD gives it serves as a reference for developing a quick understanding of the process, and it is usually denoted by blocks. Sometimes each equipment is shown as a block, or sometimes multiple equipments. Suppose one column along with the reboiler, condenser, precooler, etc. It is all shown as one block. So it is something what is shown as blocks, and it creates to create an immediate impression to the concerned party, maybe client or anyone else, to have a meaning of what is going around in the plant, or what is planned for the plant, for the new plant. That is the purpose of a BFD. After BFD, and BFD is usually prepared during the concept phase. Next is PFD, or process flow diagram. Process flow diagram, in it, all the major, or all the equipments are shown in a symbolic way, and each main pipe and each main equipment and each main control valve will be shown. And to avoid cluttering of the drawing, or to avoid so many items being shown in the drawing, minor lines, like drain line, vent line, minor bypass line, etc., they are not shown in the PFD. So it creates an initial. The PFD is always the first document which is made during the feed phase, or during the basic engineering phase. The first diagram is the first document is the PFD. Once PFD is established, a PNID will be made. PNID stands for Piping and Instrumentation Diagram. It looks somewhat like this, what is shown over here. And in the PNID, it basically indicates the detailed piping and instrumentation aspects of each equipment and each line. Each and every process item, be it major or minor, is shown over here. Like each equipment, each pipe, including half-inch, quarter-inch pipe, and each instrument, each automation connection, like so and so, say so and so instrument is connected to so and so valve, how it is connected, hardwired or through a software link, whether it is located in the field or it is located in the control room, or in the instrumentation is through PLC, SCADA, etc. These things will be symbolically shown in the PNID. PNID is document which is considered as heart of the project, and very often when any other engineering discipline other than process has to look into the design of a process, they don't come to the process engineer to ask about the design. The norm is that they just look into the latest copy of the PNID, and whatever is shown in the PNID, that is considered as a rely upon information for them. So it is common. It is called as heart of the project, or out of all the documents, the most important of all the documents is PNID. That's why in engineering companies, too much efforts are spent for the preparation of the PNID, not just the preparation, but it's review by other concerned engineering disciplines, and the review of the PNID is also considered one of the most important and the most critical aspect of the entire design activity. And not just during the project stage, even during the operation, PNID is considered as the most important thing. Whatever issue happens, the first is what commonly, commonly the PNID is referred first to tackle any kind of process-based issue. The first thing is that during operation, first thing is that the PNID will be seen, and like exactly where the issue is happening and how the PNID is structured, and it will just correlate the actual operation with the PNID. So, yeah, nevertheless, it is considered as the most important of all the process engineering documents. To add on further, whatever calculations done by the process engineer, be it calculation for an equipment, to calculate equipment size, to calculate size of line, to calculate something about automation, whatever calculation was done, everything, all the results of the calculation will be captured in the form of PNID. So it is kind of a summary document, a summary of the BFD, PFD, and a summary of the calculations, and a summary of the inputs what we receive from other engineering disciplines. And as told, it also includes minor lines, minor process and utility lines as well. So here, if anyone has anything to ask, because we are done with the drawings part. In terms of drawings, we had BFD, PFD, and PNID. Before we move on, I would like to pause for a while, and if anyone has anything to discuss or anything to ask, we may have it.
Umar, one point regarding the PNID. Once it is designed and installed, there is a review done to see as-built aspect of it before finalization. How we capture that element? Something is done in the design, but the actual it is missed. How do we capture this in the PNID?
Something we do in the design, but in actual it is missed.
Or the design has changed.
Once the design has changed, and in the can you please repeat your question? So I could not understand really. Like it is
You have the design.
The
As per one is the design, other is the design has been implemented during the construction phase, but it has gone through a modification process, and it the review. Altogether, the PNID is subjected to a review as built, right? Once the installation is over, the PNID comes before or after the as built aspect, or both.
Okay, as per my experiences, it is something what happens at the same time. Like it happens hand in hand, I can say, because during the as-built stage, there will be a detailed walk around of the entire plant by the relevant person, and it will be compared with the PNID. Whatever the gaps are there, whatever gaps are observed, in the PNID it was like this, but in actual it is like that, something else. So all those gaps will be highlighted, and usually it will be a part of the EPC contractor's role itself to update the drawing based on as-built. Based on as-built information, the PNID has to be updated. Not just PNID, other documents as well.
Okay, clear. Yeah, clear. Thank you, Umar.
Okay. Okay, I think let's have a small break of roughly 15 minutes. Okay, so that because we are halfway through our today's call, so that before we move on to the next part, we are more refreshed. So exactly after 15 minutes, we will meet again.
Yeah, okay.
wait for 1 or 2 minutes more that I can rejoin.
Umair bhai,
Yeah, please.
yeah, will you be sharing this recording in the group, or is there any other folder that you will be keeping, or you'll be sharing this on the OneDrive?
Well, I will be sharing, and exactly how I myself am not sure because it is being recorded, and it will once the recording is completed, uh, it will automatically get uploaded to my OneDrive link. So from there, can I directly share the OneDrive, or I need to download it and upload it again? That I'm not sure at the moment, but inshallah, I will be sharing it.
Okay, okay. I think you need to download it from your OneDrive, because we can't have, we won't be having the access to your OneDrive. So if you could
Okay.
download it, and if you could share a G Drive link or any of that kind, would be
Yeah.
very helpful.
Okay, okay, inshallah. Let's continue now. Just confirm once if you're able to see my screen. It's visible and it is changing, right? One of you, please, if you could confirm if the changes are being observed. Like when I change a slide, is it being seen? वलीद नूर है अब देख के कंफर्म कर सकते हैं मेरा स्लाइड जब मैं चेंज कर रहा हूँ तब चेंजेस दिख रहे हैं क्या?
हाँ देख रहे हैं सर.
दिख रहे हैं, ओके, हाँ ठीक है, थैंक यू. Okay, so let's continue. Before the break, we had seen about the deliverables or the basic deliverables, which is called as drawings. We had seen about BFD, about PFD, and PNID. Now, the next deliverable is process description. It is basically a document which is prepared by the process engineer in which the process items are described, or in other words, it is called a write-up of the PFD. Like in the PFD, each process is indicated in the form of drawings, right? But from drawings, there is room for confusion or room for different, different explanations. So because of that, a separate document is made, which is called as process description, in which the aspects shown in the PFD are described in words, starting from the initial field all the way up to the final product, and whatever process activity goes in between, it is also explained in words. Yeah, the description includes aspects like the safety, some about monitoring, about control, etc. And then after the process description, a document called as process design basis is developed. And in this process design basis document, the basis based on which the design activities will be conducted are covered, like what will be the nameplate capacity. For example, it will be 100 million tons per annum, or it will be say 1 million kgs per month, or whatever the nameplate capacity of the plant. The design capacity, for example, the plant is designed for 100, but it can go up to 110. So that's meant by the design margin. So that 110 instead of 100, 10% is the design margin. That is also be captured in this document. Then what kind of technology has been used, or what kind of technology will be used? That will also be highlighted. Like by saying the technologies, it is only about the process aspect, not about instrument technology or mechanical technology, etc. It's just about the process aspect. Like, for example, if a gas has to be sweetened, will we use a amine unit or will we use a membrane technology? Those kind of aspects are covered. And then what codes and standards will we use for this design, such as an API code or an NFPA code, or some local code. Like for example, in UAE we commonly use ADNOC DGS or ADNOC design codes. In India, we use some other codes. Like which codes we are going to use for completing this design. That will also be captured in this document. Now, what tools are we going to use? Are we going to use just hand calculations, or we are going to use some in-house calculation sheets, or will you use Aspen HYSYS, Unisim, FlareSim, etc.? What tool are we going to use? So these are aspects what will be shown, what will be indicated in the process design basis. Next is about HNMB, or heat and material balance. HNMB, it provides a detailed account of each process streams indicated on the PFD. All of us would have seen a PFD, and on the PFD we would have also seen some stream numbers mentioned, like 1, 2, or 101, 102, 103, etc. So these are some stream numbers on which are indicated on each major stream. And corresponding to each major stream, a table will be made. That table will be made either in the PFD itself or in a separate document, and that separate document is called HNMB, or heat and material balance. And basically, just a quick example, like this is the PFD. Suppose stream number for this is shown as 1. Here it is 2, 3, 4, 5, so on and so on. So for each stream, a table will be made, and for the table, and this table is developed by the process engineer. Usually it will be developed based on some software like Aspen HYSYS, Unisim, etc. Or if the process is not so complex, it is also developed by hand calculations. So the purpose of this document is to create an easy reference for understanding of the process condition. If anyone from the process team, or if anyone from any other discipline like mechanical, instrumentation, etc., has to know, like suppose I have PFD. In this stream, which is between the V-boiler and the next column, what is the operating pressure? What is the composition before this pump? So these kind of questions are answered by the HNMB, by the heat and mass balance. And so it will be kind of a detailed record in which stream or which part of the process, what are the conditions, what is the pressure, temperature, enthalpy, etc. And it serves as an input to equipment sizing and line sizing. Once I develop the scheme and once I need to start with equipment sizing, I need to know whether this column, its height will be 5 meter or will it be 20 meter or anything else. So I can, or say the capacity of the pump, okay, will the capacity be 100 or should the capacity be 200, etc. So to calculate the equipment sizes, the HNMB, the heat and mass balance, serves as a quick reference. Likewise, to do the sizing of each line shown over here, should the line be 8-inch, 12-inch, 2-inch, etc. For doing the sizing of each of the line, HNMB serves as a quick reference. Yeah, in so and so line, the size, basically the flow rate and operating conditions will be so and so. So based on that, my size will be 3-inch. Suppose here it will be 4-inch. So it serves as a reference for the entire equipment and line sizing. Okay, the parameters which are usually shown in HNMB are stream number. It is correlated with the PFD, and what is the pressure, temperature, flow, enthalpy, etc. for that particular stream. Now, one more thing I think I should be covering it with regards to HNMB, that what is the input? Like, what is the input based on which HNMB is made? Like we have seen that HNMB, heat and mass balance, it serves as an input to other concerned disciplines. But what is the input for HNMB? It is the input for HNMB, or based on something HNMB is made, right? So what is that something? Well, it is an assessment, like we start during the BFD or PFD stage itself, we will establish what will be the main product, what will be the main feed into the plant and what will be the main product. And to convert the main feed into the product, what more will be required and what all equipments will be required. Then suitable calculations will be performed. And based on the calculations, we will assess. Suppose I have feed of 100, and based on the feed of 100, I'm getting a product of 80. 20 will be byproduct. Okay, 100 feed, 80 main product, 20 is the byproduct. So to convert that 100 into 80, what more will be required? Maybe some heating will be required, pump will be required, columns will be required, etc. So all these will be established, and from suitable softwares will be used, or suitable tools will be used to establish where how much flow is going and what will be its operating conditions, what will be its composition, etc. So those calculations will be performed in order to develop a HNMB. Inshallah, when we look about Aspen HYSYS, we will be looking about development of HNMB as well. That was about HNMB. Before we move on, I would again like to pause here so that if anyone has any query, we can discuss further. Let's move on. Let us move on to operation and control philosophy. Once the drawings are completed and once the process design basis or the basis of design has been established, and once the HNMB has been developed, The next important thing is operation and control philosophy. This document outlines the philosophy of operation and control of the entire plant, from the battery limit inlet or from the main feed up to the main product, and not just main, all the inlets and all the outlets. What is the philosophy on which you will operate it? Here, the operating conditions with the entire operating envelopes will be defined. By saying operating envelope means the range of operating conditions, like minimum flow will be 100, normal will be 180, maximum 200. So the operating envelope is from 100 to 200. So for suppose minimum temperature is 70 degree, maximum is 90 degree. So for each equipment or for each part of the plant, the entire operating envelopes will be covered. Like what is the range of flow? What is the range of pressure? What is the range of temperature, under which each equipment will be operating? That will be described here. And the control aspects will also be established. What's in control aspect, it means many things. Just one or two examples. Suppose if there will be a flow control valve which works based on flow rate. If the flow increases, the control valve will slightly close, and vice versa. Flow decreases, control valve should slightly open. All the so-and-so control valve is linked to which instrument? Maybe some control valve is linked to a storage tank, or some control valve is linked to a pump. So all these linkages will also be established over here in this document. And this document also requires input from instrumentation for defining of the control architecture. By saying control architecture means how will the controls be performed? Will there be a hardwired signal, or there will be a kind of a software link, or the instruments will be linked to the control room via Wi-Fi network, or kind of any other network? And will the control be done through a SCADA, PLC, in the DCS, emergency shutdown? All these things will be detailed in this document. Another document which is related to the operation and control philosophy, but is different from it, is the startup and shutdown philosophy. A basic difference between these two documents, operation and control philosophy and the startup and shutdown philosophy, is that operation and control philosophy normally describes about the normal operation. Like under normal operation, how the operation and control will be performed. And startup and shutdown, this details about the startup, like while the plant is being started, either for the first time or after the shutdown, when the plant is started, or when the plant has to be stopped. Whatever things have to be done are outlined, or they are described as a part of this document. For the initial startup, or for the startup of the plant, there will be several requirements. Just to give few examples, like sometimes there will be some leak test, or some purging has to be done by steam. So these kind of things are explained in the startup philosophy. And regarding the shutdown philosophy, it is again broken down into two. There can be two types of shutdown. There can either be a normal shutdown or an emergency shutdown of the plant. What's the difference? Normal shutdown is the shutdown is being taken place in a controlled manner. Slowly, say the equipment will be stepped down. Each equipment will be stepped down, maybe pump speed will be slow, it will be reduced, the equipment's flow rate will be slightly decreased in a controlled manner, and this will be kept on until the plant's capacity decreases, and then stop. Or in what do we do in case of an emergency? Like maybe there will be some PSV or some safety valve which will be opened, or some blowdown requirements will be there, or automatically a pump has to immediately stop, say within 1 or 2 seconds. As soon as something goes wrong, immediately equipment has to stop. So there's a difference between you stop a plant under like normal in a controlled manner or in an emergency manner. So both the procedures or both the philosophies will be outlined in this document. Now, what are the requirements? What things we need to do during and after the shutdown? Maybe we have to do some venting. We need to do some blowdown, or some cooling requirements are there. Or then what will be the control valve fail-safe position for each control valve, and for each automatic valve, there will be a fail-safe position already defined during the design stage. If the control valve fails, will it be in open position or will it be in closed position? So these things are also described in this document. Now, methodology of the shutdown, like will the shutdown take place through a DCS or through an ESD? Then again through a hardwire, or through a software link, or anything else. So these kind of things are explained in this document. Till here, anyone has any further doubt, any discussion?
Yeah, Umar bhai, assalamu alaikum.
Islam.
Am I audible?
Yes, yeah, you are audible.
Yeah. It's not a doubt. I just want to add something. This is not related to this particular slide, but this before slide.
Sure.
Just correct me if I'm wrong or need to be added something. In previous slide, we have seen that in the control philosophy, we have to like show or mention each and everything regarding the controls. What kind of control will be there? So I'm just telling, for example, maybe it is automatic or something. SCADA will be there. Any regarding any wall or like that. So basically, I would like to ask one point. This is we will be outlining whatever is pre-decided. So what kind of control we are giving to the client, or the client particularly wants for their processes, but it is decided. It is a very like pre-feed, we can say, or we can say at the proposal stage only, where the scope of work or the requirement of the clients has been decided. So at that time only we will be deciding what kind of the controls or what kind of equipments will be giving for that particular process, and depending on that, the costing also will be affected for the overall plant or overall process. However, this is differ on the project basis or client requirements, but whatever is pre-decided according to the process, that only we have to like provide to the client on a like firm deliverable basis in the control philosophy.
Yeah.
Am I right, Mr. Umar bhai?
Yeah. Here, what you have mentioned is about something which is already pre-decided.
Yes.
That is also something what varies from a project to project and from company to company. and it varies based on the nature of the type of the contract. Like there will be some clients
Yeah.
who in the scope of work initially, in the scope of work itself, they will mention in detail about the control aspects.
Yeah,
So in that cases, the engineering contractor, whoever it is, like the process engineer, instrumentation, etc., they have to just stick to that. Whatever it is, they need to stick to that. And in that case, this will be just an elaborate description of the scope of work. Or
Yes.
in some cases, from the client side, the entire scope of the work, even though the project might be in say hundreds of millions, but in some cases I have heard that the scope of work will not be more than one page. So in those cases, this type of control aspects will not be detailed, and it is the engineering contractor or it is the engineering consultant who needs to do the design in detail. Yeah, and the client has to approve or reject. Yeah, and ultimately, the main audience, not audience, or the main people who will be the main concerned discipline who will be using these documents are instrumentation, and second is the instrumentation system company. Like there will be some contractor who will be appointed in order to implement or incorporate the instrumentation controls. Whatever the engineer or whatever the engineering contractor has defined in the document, it should actually happen in the site, right? So there will be one company or there will be one team to actually make those things happen. So they are the main users of this operation and control philosophy and short-term shutdown, etc. So yeah, even though if it is mentioned in the scope of work, it has to be elaborated in the engineering documents, such that the team who actually implements it in the field, they need to be aware of it, or they are well aware of what's happening. Please mute your mic. If anyone is not speaking, I would request him to mute his mic. Next document, which has to be prepared by the process engineer, would be the tie-in philosophy, or tie-in, like how you are going to tie in with the existing system. In most of the projects, some plant is already there and an additional plant will be built. Some equipment or some packages are already there and additional equipment or additional packages will be installed. Yeah? That could be to increase the production or to overcome some maintenance issue or anything. New plant is made and it has to be tied in or interlinked with the existing. So this document called as tie-in philosophy is also prepared by the process engineer, which covers the philosophy of how it is going, how the new will be linked to existing. And the aim of the tie-in philosophy document is to ensure that there's a seamless integration between the new and existing piping, such that the entire system functions as just one cohesive unit. Means what? There will be several existing pipes, sometimes in brownfield jobs. Okay, when I say about brownfield jobs, just pause here for a minute, and I would just like to explain about what is meant by brownfield and greenfield jobs. When the entire plant is being designed from scratch, everything is done new. There's nothing existing, everything is done from start. Those kind of projects are called as greenfield projects. And brownfield is the opposite of it. Like some plant is already there, but new plant is made, or some additional equipments are installed, such that each equipment will be linked to the existing. So this kind of thing, something is already there, put something more. That is called as the brownfield projects. So yeah, in brownfield projects, this document on time philosophy is most required. And in brownfield projects, some in the projects which are of a very large scale, there will not be just one or two, but might be hundreds or sometimes even thousands of new pipes which have to be linked with existing piping. So the new has to be integrated in a very sequential, structured, and organized manner. There can be many aspects if the tying is not done well. Few examples. Okay, one thing is just visual. Some pipe was used of certain grade, other pipe was is used of any other grade. That is where the corrosion issues now. Or maybe some kind of hazardous fluid is flowing, or some kind of corrosive or hazardous fluid is passing through a pipe, passing through a new pipe which is not designed to handle that hazardous flow. Okay, so there can many such things. So ultimately ensure that it is the new is clubbed with new, the new is clubbed with existing in a very structured manner. That is one of the reason why this document is made. And risks of leaks and other maintenance issue are like minimized, and they're made such that maintenance and repairs can be carried out easily. Now, for each of the times, what type of time will be required? This is something what the process engineer will not be deciding, but this is rather the piping engineer or the mechanical engineer who has to decide this. For each type of time, for each type of new and existing time, does it have to be drawn by welding, or by a flange, or by a thread, or anything else? That's about this document. Next is about vent and drain philosophy. This document basically covers the philosophy of emptying of the contents of the process plant. If the process plant has got several liquids, gases, solids, two-phase, three-phase, etc. So when we want to empty it out, how are we going to empty out the plant? Like normally, gases are emptied out through vents, liquids are emptied out through drains, and what more? So it's all about that. How are you going to empty out the plant? Or how are you going to empty out the contents of the plant? Now, emptying is also can be of either it can be normal emptying, or it can be an emergency emptying. Normal emptying usually done through scheduled draining or venting, and emergency emptying is done through depressurization valves, blow down lines, or PSV reliefs. So how under normal conditions, how are we going to empty out the contents? Under emergency conditions, how are we going to empty it out? It is covered in this document. And philosophy for the selection of drain and vent lines fibers is also established. Based on what are we going to select the drain and vent line size? There are some codes and standards which say that in so and so place, the vent line should be at least 2 inch or at least 4 inch. based on based on other criteria such as noise, such as pressure drop, velocity criteria, or based on any other criteria, how are we going to establish the size of the drain and vent lines? Those details will also be covered. And also the destination of the emptied fluid, whichever fluid, either liquid or a gas, once it is emptied out, where it will go? Will it go to an open drain? Will it to a pond, or will it go to a closed drain, or will it simply be routed to atmosphere in some safe location, or will it be passed into a flare or anywhere else? So where, after emptying it out, where it will go? That is also an important question which needs to be addressed. And once addressed, it will be covered as a part of this of the document. Any suggestion, or I mean any queries or any doubts?
Umer bhai, there is any format, standard format available to prepare the control philosophy? I heard about the sequential flow chart, but I am not aware about the any standard format of it for control philosophy.
Okay. Okay. Format, now it is something what each company has its own format. I can also take something and I can share it with you. But yeah, the bottom line is the same. Like it has to cover like irrespective of the format, it has to cover all the operating envelope from the like each part of the plant. Its operating envelope must be covered and its control envelope must be covered. That is the basic thing. Now, company to company, project to project, the format may vary.
Okay.
After vent and drain, let us go to another document called as process safeguarding memorandum. Like how are we going to safeguard the process, or what are the levels of safeguard, and what is the philosophy, or what is the way in which the safeguard will be established? So those things are covered in this document. One of the basic thing is having an ultimate safeguard for any safeguard, or to safeguard any plant, to avoid any mishap or to avoid any accident happening. There are 3 levels of safeguard. The first level is the design pressure itself. It is the inherent, it is kind of inherent safeguard. To explain this further, suppose a plant or a particular part of the process plant is operating at a pressure of 8 bar. Okay, the operating pressure is 8 bar gauge, and the design pressure for that plant, for that part of the plant, is 12. So 8 is the operating pressure, but it is actually designed to withstand a pressure of 12. So that additional 4 bar margin, it itself is a safeguard. What if the pressure increases all of a sudden? What if something goes wrong? So an inherent safeguard is there. 8 is the operating, design is 12, 4 is a safeguard. Likewise for the temperature, if suppose a part of the plant operates at a temperature of say 70 degrees Celsius, it is designed for say 85 degrees Celsius. So operating at 70, design at 85. So the balance, the extra margin or the operating temperature is a safeguard. So that is the first level of safety. Having a design pressure and temperature slightly higher than the operating envelope, it itself is one of the safeguard. Next safeguard is alarm and trip, and it is okay. It is in terms of instrumentation safeguard. If anything goes wrong, automatically some valve has to open, or automatically some valve has to close. Or suppose in this example that I gave, 8 bar is operating, 12 is the design. So that several times this is done. If the pressure goes to 10, operating 8, design is 12. Pressure, because of any reason, the operating pressure increases from 8 to 10. So at 10, there will be a high pressure alarm, like some alarm to indicate the operator that something is going wrong, take care. So at 10, there's an alarm. And if in spite of going at 10, the pressure continues to increase, pressure goes to say 11, then there will be a trip. Something will close or something has to close, and what will close again has to be decided by the process engineer. But yeah, something has to close, and or something has to trip, because of which if the pressure goes to 11, it will again come down, or it will not move further higher up. So operating was 8, alarm is at 10, at 11 there's a trip, and suppose if trip is not working, or trip has failed, or something has gone wrong, then there will be a PSV, or called as a pressure safety valve. So that is the ultimate safeguard in terms of hardware available. So the PSV will open up, and again the pressure will come down, and it will avoid any accident from happening. Or explosion doors for boilers and for heaters. So this kind of safeguard, first is the inherent safety in the form of a design pressure, then some instrumentation safeguard in the form of alarm and trip list, then safeguard in the form of PSV or the explosion door. So these are the levels of safeguard which need to be made available for each plant in order to ensure that it works safely. So these kind of safeguards will be explained in this document. Likewise, some mitigating systems like emergency shutdown valves or emergency shutdown systems, etc., will also be detailed in this document. Next is about cause and effect diagram. This is another document which enlists all possible process deviations along with the respective recommended effects on the process plant. Okay. In the plant, there will be several others, or there will be several aspects. Based on it, something has to be defined. Just consider an example to understand this better. Automatic closure of tank inlet valve on attaining high tank level. Suppose some liquid is being poured into the storage tank. Okay, there's some storage tank, some liquid is being poured into the storage tank. What if the level goes high? If the level exceeds a particular limit, there will be overflow of the contents of the storage tank, right? So to avoid that happening, there will be or there has to be an automatic system in which as soon as the level goes exceeds a particular limit, the inlet valve has to close. So what do you say here? The cause is the level of tank going high, exceeding a particular limit. And because of that cause, if level goes high, the effect should be that the tank inlet valve has to close. Yeah. And if the tank inlet valve is closing, maybe the pump which supplies liquid to the tank should also trip. So once again, cause is that level goes high. And because of level going high, inlet valve has to close, pump has to trip. So that is an example of cause, level going high. And what's the effect? Inlet valve close, pump trip. So that is one example of what will be mentioned in this document. So like this, there will be hundreds or sometimes thousands of causes in the entire plant. And based on so and so cause, this has to be the effect. Based on this cause, that effect. So a list of all the causes applicable for that particular plant will be described in this document. Another thing which is related to cause and effect is alarm and trip list. This is another document which has to be made by the process engineer, in which the details of each alarm and trip the values of each alarm and trip will be mentioned. Just the example of what I gave in 8 bar was the operating pressure. At 10 there will be an alarm, and at 12 there will be a trip. So the list of all the alarms of all these values of all the alarms applicable for that particular plant, along with the trips, will be mentioned in this alarm and trip list document. And although not the same always, but usually it lies under these values. If the value goes to 80 to 90%, an alarm has to ring. 90 to 95%, it has to trip. Just consider an example of a level. Okay, suppose there's a vessel in which the level can go anywhere between 0 to 100 inch. Okay, level of liquid can vary from 0 to 100 inch, and normally it should be somewhere at half, or it should not be below 20% or should not be above 80%. But because of any reason, if the level keeps exceeding till it reaches 80 or 90% range, there should be an alarm to alert the operator that something is going wrong, immediately take action. And if operator fails to take an action at 90 to 95% of the level, it has to trip automatically. Likewise, if the level comes down below 10 to 20%, there will be an alarm. And if the level goes below 5%, it has to trip. Like, this is just an example. Now, from case to case basis, the value varies. And this is true not just for level, for other parameters as well. It is applicable, like pressure, temperature, concentration, flow. Suppose if one example, if an online analyzer is used to measure H2S, for example, if the say up to 100%, up to 100 ppm of H2S, it is fine. But if the H2S concentration goes above 100, an alarm should ring. If it goes about 200, it should trip. Something like that. So this is not just for level, for all the process parameters, all applicable alarms and trip. For all the applicable alarm and trip list, there has to be some kind of setting, and the setting value will be decided by the process engineer. And yeah, And based on all these values of all the alarms and trip in that particular plant, this document called as alarm and trip list will be made. One thing to be noted over here, the three documents what we have seen, it is an operation and control philosophy, cause and effect diagram, and alarm and trip list. These three documents serve as an input for instrumentation system implementation. Like, why do we make this kind of document? Ultimately, it is for the ultimately it is for that team who is going to implement it in the plant, who has to implement the automation in the plant physically. For them, these documents will be very much vital, very much required. Like, this will be a basis for them, and that's why these documents are made, to ensure that the instrumentation and automation is well established. So till here, if anyone has any doubt, any query, please address. Okay, so let's move on. Our next topic or next important deliverable is line list. A line list, it provides a list of all major and minor lines indicated in the PNID. All of us have seen a PNID, and in the PNID, we have seen that each line is assigned a particular number, and for each line, the details of each line are mentioned, or the details of each pipe are mentioned in a separate document called as line list. Line list is made so that it serves as an easy reference, or serves as an input to piping and instrumentation disciplines. Yes, an example, if I had a PNID over here, if any other discipline during the design phase or even in operation phase, if anyone wants to know that what will be the density in this line, the line which comes from here to here, what will be the density, or what will be the operating pressure, or what will be the design temperature, based on those parameters, the instrumentation engineer will purchase the control valve. So it is very much vital, it's very much important to have the details of each and every pipe. So this line list document creates, or it gives a detailed information about each and every pipe in the PNID. Now, what kind of information will be shown in the PNID? What kind of information will be shown in the line list? Information like PNID number, like so-and-so line, which I am mentioning in my line list, it is in which PNID? And what is the line number? And where is the line coming from? Say it is coming from a vessel. Then where is the line going to? Say it is coming from a vessel, going to a compressor. So that should also be mentioned. It's coming from vessel number so-and-so, going to compressor number so-and-so. And what are the operating pressure and temperature of that particular line? What is the design pressure and temperature of the line. What is the flow rate, what I'm expecting in that line? What is the velocity? What is the speed through which fluid will be moving in the line? What is the density, viscosity of the fluid in that line? What will be the size of the line? 10 inch, 8 inch, 2 inch, etc. What will be the fluid? Will it be a hydrocarbon, corrosive, or liquid, or hazardous fluid, gas, etc.? And which unit or which area will the fluid is passing into? Each plant is divided into certain areas, right? A, B, or certain. It is called by the names. So which area that line will be passing through? So these details will be defined by the process engineer, and it's not just the process engineer who makes the line list. Rather, it is the typing engineer also who needs to give the inputs for making line list. Like, what are the inputs? What is given by the typing engineer? Details like the stress criticality on a particular line. Will there be more stress or less stress? I mean, it is a stress critical line or not? Then what is the hydro test pressure of that particular line? What is the class on which of that particular line? Is it, say, 150 class rating, 300 class rating, or any other thing? What type of insulation is required for that particular line? What is the insulation thickness? What is the schedule? Whether it is ANSI, say ANSI schedule 40, schedule 80, etc. So these details will be furnished in order to have the line complete, in order to have the line list completed. And ultimately, once it's made, it will serve as an easy reference for other disciplines in order to carry out their design. Okay, till here, if anyone would like to add anything or any query. Okay, let's continue. The next topic is on equipment datasheet. Equipment datasheet is a document which is usually, although it is owned by mechanical. By saying owned means it is the responsibility of mechanical discipline, but inputs are given by process engineer. Now, for each equipment, either it is a vessel, storage tank, pump, compressor, etc. For each equipment, a data sheet will be made. And why the data sheet is made? Because the data sheet, it is made by the engineering team comprising of process and mechanical, and ultimately it is given to the supplier, or the data sheet will be given to the vendor, so that vendor can develop his design, or vendor can provide his cost. That is why equipment data sheet is made, or it is kind of a thing in which the engineering team transmits the information to the vendor by means of the data sheet. Like, through the data sheet, the engineering team conveys to the manufacturer or conveys to the vendor that I want this equipment, it should have so and so specification. So all these kind of specification for each equipment is captured in a document which is called as equipment datasheet. What does it contain? Let's look into that. For each equipment, the equipment datasheet defines the envelopes of flow or the ranges of flow, temperature, and pressure. It also defines the maximum and minimum design temperature and pressure. Suppose an equipment will be operating in 10 bar gauge. Its design pressure should be 12 bar, suppose 12 or 14. Okay, there are certain other standards and code which tells that what should be the design pressure. That's a separate discussion. And okay, so this entire envelopes of operating and envelope of design pressure and temperature will be established in the equipment list. And what will be the tentative size of equipment? How many nozzles will be there? Suppose the equipment will have 8 nozzles, one for inlet, outlet, drain, vapor outlet, emergency outlet, etc., etc. So how many nozzles should be there? What will be the size of each of the nozzles? This is also something what is the process engineer's responsibility to say how many nozzles it will have and what will be the size of each nozzle. If the nozzle is undersized, it might create issues like too much vibration or high velocity leading to vibration and leading to early damage to the equipment. So yeah, what is the tentative size? This big, this big, this big diameter nozzle, where it will be located. So these are the inputs what will be established by the process engineer. And mechanical engineer will again define his inputs, which will be more detailed. For instance, what will be the thickness of the vessels, what will be the support requirements, and other things. Now, just thing to be noted here that what we, if anyone is into process design, he will experience that in some cases, or especially in large scale projects, there will be, for each equipment, there will be 2 separate data sheets. One will be made by the process and another will be made by mechanical. So that the process, the equipment process data sheet will only consist of the process based information, and the mechanical engineer will based on the process data sheet, the mechanical engineer will produce his separate data sheet which will be more detailed. But in small scale jobs, there will not be 2 separate documents. It will be just one data sheet document for each equipment. And okay, based on the inputs given by the process engineer, the mechanical engineer will own the data sheet, or he has to take the responsibility for the data sheet based on inputs given by the process discipline. Another thing which is identical to equipment datasheet is instrument datasheet. What we had seen over here, it was for equipment, for each equipment in the plant, and it was kind of interface between process and mechanical. Now, instrument datasheet is kind of interface between the process and instrumentation disciplines. Again, it is owned by the instrumentation. Like instrumentation engineer has to take the responsibility of instrument datasheet, but yeah, obviously it has to be made based on inputs received from process engineers. Again, identical to equipment datasheet, the ranges of operating pressure, operating temperature, flow, what is the design pressure and design temperature. All these things will be established in the instrument data sheet. And what will be the minimum required instrument range? It will also be specified, and this has to be given by the process engineer, because the process engineer, based on his calculations, he will know the operating envelope. Suppose we have a flow indicator, and the process engineer, based on his calculations, he knows that under this particular, or through this particular flow instrument, the flow rate will, minimum flow will be 100, say tons per hour. Maximum flow will be 200. Minimum flow will be 100, maximum will be 200. So the process engineer will say that I want this instrument to measure the flow at least from 100 to 200. Above that or below that, it is up to the instrumentation engineer, up to the vendor, based on availability of instrument. But at least this range of 100 to 200, that has to be covered by this particular instrument. So this, the ranges of all the parameters, that has to be given by the process engineer. Then very often, if it happens, I mean, based on experience, that if process engineer tells that I want this instrument to measure up to 200, but the instrumentation engineer, based on availability of instrument and based on his experience, he might have an instrument which can measure up to 300 also. I mean, it will usually be slightly higher than what the process engineer requires as a bare minimum. Again, for instruments like control valves, what will be the control valve CV, what will be the size, that will also be indicated. Now, for instrument means all kind of process instrument which are required to measure pressure, temperature, flow, level, concentration, etc. All this, for all the for whatever instruments are there, a data sheet has to be made. Again, like that of a equipment data sheet, if the project is quite small in nature, usually it is for each instrument only one data sheet will be made. But for large scale projects, two separate data sheets will be made. One will be by the process engineer, other will be by the instrumentation engineer, which will be much more detailed than the process engineer's instrument data sheet. It's all about this. And hazard analysis topic is something which is quite large. I mean, just to cover this hazard analysis topic, it will need some good amount of time. So we can keep this hazard analysis for our next week workshop. And it is almost 11:20 over here in UAE. So we can use the remaining time of this workshop to have some general discussions. If anyone would like to have more clarification on what we have already discussed, you can have it.
Umair bhai, this weight line size and flare design, means stack design is included in this workshop, na?
Yeah, that will
Weight
also
line
be.
size.
I think let me just have a quick check if it is station from computer station. Oh yeah, that will also be there. as a part of this
Okay.
workshop. And okay, we'll also have a quick check on the agenda, like on like that, where are we, where we have reached, and what we are yet to cover. This was our agenda. We have seen the objective, some general items we have seen, and we have seen all these things like the BFD, PFD, PNID, process description, uh, design basis, HNMB, OCP, startup philosophy, tie-in, vent and drain, safeguarding memorandum, cause and effect, alarm and trip list, line list, and equipment and instrument data sheets. We are yet to continue on hazard analysis, and the topic what we will be seeing after hazard, which is some basic concepts commonly used. That is something what will be the main, you can say it will be the heart of this workshop. It will just be we'll be covering up inshallah the basic concepts, what what every process engineer would be expected to know. Besides this basic concept, there are several other things which can be covered, and if time permits, inshallah, we'll cover a few other things as well. But yeah, these are some basic questions, and if we go to any interview for the process engineering role, I can say that at least half of the questions will be around these topics only: line hydraulics, pump hydraulics, heat exchanger, column, control well, and yeah. Inshallah, we'll also look at some case study on some process engineering software. And lastly, yeah, we'll be covering some of the job hunt aspects as well. There was one request by one of the participants. I would just like to address it over here. One of the participants had requested me that the next week's workshop, if possible, we could postpone it to the week after. Now, like instead of having it next week, we can continue it on the next to next week, and we can have the last workshop in the first week of January. So this was a request by one of the participants. I would also like to hear from all. Like, I believe those who are available over here, I believe you will be continuing till the end. So I would like to hear from you, if you have any opinion to it, or no. It is, on the one hand, it is good to have everything in one go. If will everyone over here be available?
Better to make so one go, as or we can change the time also.
Yeah, okay, noted. And will all of you who are available over here, will you also be available on Saturdays? Or if there's anyone who cannot be available on the Saturdays, please let me know.
Sorry, Saturday we are not available.
You are available. Okay. Yeah, okay, that's fine.
Umer, I will not be available from 27 to next year.
Okay, next year, fine. Okay. Okay, 27, you will not be available. So yeah, basically everyone has. Yeah, understand. Okay, so considering this, I think let us continue. Let us continue with our workshop. I mean, as planned. next week we will be having, and we'll also have it on the week after that. And so it's best that we complete everything by December, because it is also considered to postpone it, but again everyone will be having his own his own schedules. Like if you postpone it from next week, like next week's workshop, if you postpone, there might be someone who will be able to attend next week, but not in the week after that. Amma, do you have any opinion on this?
No problem from my side. Anything is up to you, depending on the everyone's availability. For me, the Saturday also possible, and if you postpone from next to next week, that is also okay. No problem from my side.
So let's continue. So let's continue next week. And anyway, the recording will be shared. So if anyone will be missing any of the workshop, and if you would like to know what happened in the workshop, you can refer to the recordings. Okay, so if anyone has to add anything more, or anyone want to clarify anything further, it's on the today's workshop.
Okay, thank you.
Welcome. All right, so let's call off the current session, and thank you all for joining in, and hope to see you in the next workshops as well.
Thank you, man.
Assalamualaikum warahmatullahi wabarakatuh.